Hi, hello, good morning, my dear students. Welcome back to my YouTube channel, Kayaka Maths Classes. So, today we are discussing mathematics class for PUC second year students, that is chapter number 1, Relations and Functions. So, today we'll discuss some of the basics of the first concept in this chapter, that is the relations. So, the things are definitions and some of the types of the relations, because this chapter is very very important as far as the theory as well as the CET is concerned, because we have seen or we have learned the same chapter in PUC first year also. So we have some different kinds of concepts as compared to the class 11, that is PUC first year. Okay, so I request my dear students to please subscribe to my channel so that you can get a notification of every class. So please watch this video till the end so that you can easily clear your doubts, so that you can learn the concepts step by step with easy methods. Okay. So chapter weightage. So we'll discuss theory as well as Karnataka CT. So 1 mark questions, that is one question will be asked. Sometimes they'll ask two also, but most probably one multiple choice question will be asked. So 3 mark question, one question, and similarly 5 marks. So one question will be asked from this chapter as far as theory is concerned. So for KCT, so total 9 marks and number of questions are 3. Okay. For KCET, 2 to 3 questions will be asked. Sometimes 2, sometimes 3. So if we include the first year chapter also, we have a relations and functions. So they may ask 3 to 4, sometimes 4 to 5 also. So there will be plus or minus one question in the Karnataka CET. So okay, 9 and 2 to 3 questions, isn't it? Okay. Now let us see. So before going to start the class 12 relation and functions, so I'll just take 3 to 4 minutes to revise some of the important definitions as well as important key points related to class 11, that is PUC first year basic definitions, because those are going to used in this chapter, that is in second year. Let us have a quick revision in 3 to 4 minutes. Let us say, so Cartesian product, this is very important. So let us take the two non-empty sets P and Q, and the Cartesian product is denoted by P cross Q and is a set of all ordered pairs. You should know these things of the elements from P to Q. This is very important. P cross Q represents the Cartesian product from the P set to Q set. Okay, right. Let us say. Now, what is ordered pair and all the things? Let us say here. Okay, how it will be represented. So P cross Q, that is mathematically it is represented as. So this is called as ordered pair. Small bracket P comma Q, where the first element P is the element of first set and the second element Q is the element of second set Q, where this element P belongs to P and Q belongs to set Q. Okay, right. Now let us have one important point also. If either P or Q is a null set, which means if P is null set or Q is null set. Null set is there are no elements present in either in P or in Q. Any one of the set is empty. Either P is empty or Q is empty. Then what is its cross Cartesian product is nothing but what? If any one of the sets are empty, then their Cartesian product is also empty. That is a null set. Okay. Let us take an example. If A is having the element XYZ, B is having the elements 1, 2, 3, and he wants to find A cross B, that is Cartesian product from A to B. So you should have the combination of elements of A to all the combinations of elements of B. So there should be a relation from A to B, that is every element of A should relate to every element of B. Okay, let us see how it will be. So how we are writing? We are writing the ordered pairs. We are writing the elements of Cartesian product in ordered pairs. That is small bracket. So first element is the element of first set and second element is a set of second set. You can see set A is having XYZ and set B is having 1, 2, 3. Okay. A to B in the sense, of course, first set will be X. So X is related to 1, it is X, 1. X should be related to 2, X2. X should relate to 3, it is X3, X2, X3. Similarly, Y related to 1, y related to 2, y related to 3. And similarly, we can write z1, z2, z3. So we can write all the possibilities from the set A to set B in the ordered pair form. This is small bracket followed by separated by commas. That's it. We call it as a Cartesian product of two sets A and B, isn't it? So we have already studied this in PUC first year. So we are doing just a quick revision. Now let us start the class 12 with the basic definition, that is relation. How do we define the relation? On what are the aspects we need to define a relation? First thing, to define a relation, we need two objects. For example, in generally, if a brother sister, what is the relation between them? If two persons are there, what is the relation between them? Whether they are friends, are they brothers, are they brother and sister, what is the relation? So we need two elements, two subjects, two objects. So here what we need two sets. Let us take a relation from a set A to set B. We are setting a relation from set A to set B. This is important, my dear students, is a subset of the Cartesian product of A cross B. Is the subset, which means Cartesian product will have all the possibilities we have seen in the previous example also. That is why I have given the introduction of previous year, that is class 11, some of the important points as well as Cartesian product also. Okay, so Cartesian product will includes all the possibilities. If some of them include it, then we call it as a relation. Let us see by using the diagram. Okay, so let us take a set A and we'll take this as set B. Okay, now x is related to 1, y is related to 2, and z is related to 3. Okay, so what will the ordered pairs, what will have? X comma 1 and y comma 2 and z comma 3. Okay, so this is your A cross B. This is your relation. Okay, so if we have a relation, that is if you have Cartesian product A cross B, so A cross B in sense what you have? x1, x2, x3, y1, y2, y3. Cartesian product in the sense you should write all the possibilities. If some of the possibilities are there with some conditions, then we call it as a subset, because these elements belongs to the Cartesian product of A cross B. Okay, so already I have discussed same example. You can go and watch in the previous 2 to 3 minutes back. We have written all the Cartesian product. If I have picked some of them, we call it as a subset. Okay, in general, if I say if set A is having the element 1, 2, 1, 2, 3, 4, 5, and so on up to 10, and if I say the elements as B as 2, 3, 4, can I say B is subset of A? Because the elements 2, 3, 4 belongs to set A also. Similarly, this relation of the elements belonging to the set A cross B. So this is the definition of a relation. It is a subset of the Cartesian product of the two sets, that is A, B, or it may be PQ, isn't it? Okay, this is simple, my dear students. Are you following this? Please concentrate here and listen carefully. Definitely you will understand the things. Okay, and learn with practicality. So I've given examples also. Okay, now let us see. Let us move to the next one. The next topic is types of relations. Let us see. So first one is empty relation. Okay, so let us define it. A relation R where no element in the set A is related to any element in the set B. That is a relation with no ordered pairs. So we have two sets A and B, and no element of A is related to no element of B, which means there is no relation, there is no ordered pairs also. Let us see with an example also. Let us see. So if I take this as set A and this is set B, my dear students. Okay, now if I make an arrow like this, this represents x is related to 1, but here we are not related. Now you can see this is also empty, this is also empty. There are elements, of course, A is having element, B is having elements, but no relation. Then you cannot write x comma 1, x comma 2. There will not be no ordered pairs. There will not be no ordered pairs. Okay. The second one is universal relation. It is exactly opposite of the empty relation. A relation that contains all possible ordered pairs of A cross A. If suppose A is the set, then A cross A should consist all ordered pairs. Okay. For example, if set A is XYZ and if the set B is 1, 2, 3, then X should relate to 1, X should relate to 2, X should relate to 3. And how we write ordered pairs? X comma 1, X comma 2, X comma 3. Isn't it, my dear students? Okay. Then similarly, Y should relate to 1, Y should relate to 2, Y should relate to 3. So what we write? Y comma 1, Y comma 2, and Y comma 3. Similarly, Z will relate to 1, Z will relate to 2, Z will relate to 3. So how we write it as Z comma 1, Z comma 2, Z comma 3. Okay. And we have one more also here, my dear students. This is not all the possibilities. So one more is X relating to, there is no element. No element in the sense null set. Yes, that is also important. So some of the elements are related to null sets also. X related to null set, Y related to null elements also. So that is also a part. So you can say phi is also a subset or a part of the all possibilities of a ordered pairs. Okay. So this is universal relation. You can write all the possibilities in it. Okay. Now, so one more is identity relation. Okay, what it is? A relation in which every element is related to itself. Itself in the sense, if there are two sets, relation in the sense we need two sets. So first set of elements should be related to second set of elements. That is, there should be same number of elements in the first set as well as second set. In the previous set, we have taken x, y, z and 1, 2, 3. Here we need to take x, y, z in both, or 1, 2, 3, 1, 2, 3. Let us see with an example. Here you can see, if I take this as A and this as B. Okay, so 1 is related to 1, 2 is related to 2, 3 is related to 3. Here you can see it should relate to itself. 1 cannot relate to 2 or 1 cannot relate to 3. It should relate to itself. That's it. Okay. So instead of that, let us take this A also, because both are same instance. You will take it as set A cross A only. So it is called as A cross A. Okay. This is identity relation. Okay. Are you following this? These three are the basic definitions of the types of relations, my dear students. Okay. Now we'll have some of the very important definitions also. So we have another 3 to 4 definitions. Please concentrate on this because you are going to solve the examples on this only, and 1 3 marks question will be asked from these definitions compulsory in your question paper. Every time, every year, there is one question in your question paper for 3 marks, 101%. Let us define them. The first one is equivalence relation. Okay, how do we define the equivalence? Let us see. A relation R is in a set A is said to be an equivalence relation if R is, okay, let us see, if R is reflexive, if R is symmetric, and if R is transitive. Okay, if a relation R for a defined set, it may be set A, B, or C. Here in general we have taken it as A, is said to be equivalence relation if it should satisfy these three conditions, that is reflexive, symmetric, as well as transitive. Now you should know how to define them, how to know them. That is very important, my dear students, because proving reflexive, symmetric, transitive is very important. Okay, let us see, let us define them also so that we can define the equivalence relation easily. First one, reflexive relation. Okay, let's define them and we'll see an example. Okay, a relation R in a set A is said to be reflexive relation if Mathematically, what we write? A comma A belongs to R for every A belongs to A. Okay, which means reflexive in the sense it is like a mirror. Reflexive. What you see in the mirror, the same will be reflected to you. Okay, it is like a mirror image. It is like a mirror image, my dear students. Okay, if the first element is A, second element should also be A. Then if these two belongs to the relation R, then we say the relation is reflexive. So for example, let us take, if I take the set 1 2 3, we need a set compulsory. Okay, if relation contains the elements ordered pairs 1 comma 1, 2 comma 2, 3 comma 3. So if 1 is there, you should have 1 comma 1 compulsory. If 2 is there in the set, it should be 2 comma 2. If 3 is there, it should be 3 comma 3. So if all this belongs to the relation R, then we say that R is reflexive. R is reflexive. Otherwise, if for example again, if we consider R is equals to 1 comma 1 and 3 comma 3. So what we say here, 2 comma 2 does not belongs to R. Therefore, R is not reflexive. R is not reflexive. So if the set containing 3 elements, their same ordered pairs, that is mirror ordered pair, should be present in a relation. All of them. If anyone is missing, it is not a reflexive. Okay. If A, B, C is having the set, it should contain A comma A, B comma B, C comma C. If any one pair is missing, so it is not a reflexive. Every ordered pair must be present with the same element as of the set A. Okay, is it clear now? Okay, here all 1 1 2 2 3 3 are present, so it is reflexive. So here 1 1 present, 3 3 present, but 2 comma 2 is not present here in the second example. That's what it is not reflexive. Simple. Okay, let us see. So symmetric, it is very simple, my dear students. Okay, in a relation R, in a set A is said to be symmetric relation if A comma B belongs to R. So what is saying, if A comma B, which means the first ordered pair belongs to R, then what we need to check, B comma A should also belongs to R, where A and B belongs to the set A itself. Let us take an example, my dear students. If A is equals to 1 comma 2, 2 comma 1, 1 comma 1, 2 comma 2, and so on. If this is a relation R, let us take this is a relation R, and let us take set A as 1 2 3 only. Let's take the set as 1 2 3 only, and this is relation R. Okay, relation R is containing the elements 1 comma 2, 2 comma 1, 1 1 2. Okay, if A comma B belongs to R, A comma B in the sense A should be different element, B should be different. So here 1 comma 2 belongs to R. So this is like A comma B. Okay, this is like A comma B. And what we need to check is 1 comma 2 belongs to R in the sense whether 2 comma 1 also in the relation or not. You check 1 comma 2. So here we are having 2 comma 1. So this implies 2 comma 1 it also belongs to R. Okay, therefore R is symmetric. So when it is not symmetric, let us take another example also. If I take example 2 comma 3, 1 comma 1, 2 comma 2. Okay, so here you can see 2 comma 3 belongs to R, but 3 comma 2 does not belongs to R. Does not, we'll write like this. We cancel that. Belongs to cancel. Okay, here you can see 2 comma 3 is there, and what we need to check, if AB belongs to R, you need to check BA. BA in the sense 3 2. So there is no 3 2. So 2 comma 3 belongs to R, 3 comma 2 does not belong to R. So it is not a, this is not a symmetric. Is it clear, my dear students? When we say it is reflexive, when we say it is symmetric. Okay, let us see. One last, transitive relation. This is very important, my dear students. Just concentrate here. A relation R in a set A is said to be transitive if for transitive we need three sets. Okay, let us see. If A comma B belongs to R and B comma C belongs to R, this implies that A comma C belongs to R. Okay, this is very important. Let us take, if R is having 1 comma 2, 2 comma 3, 1 comma 3, 1 comma 1, 3 comma 3, 2 comma 2. If this is a relation, A B belongs to R. Let us see A B and C are two different things. 1 comma 2. Let us take this as A comma B, my dear students. Okay. So this belongs to R because this is already there. Now BC in sense B is 2 here. So the element should start with 2 only. BC. Here it is, an element is starting with 2. So BC is nothing but what? 2 comma 3. C is again different thing. So this also belongs to R. Then what is AC? This is A is 1, C is 3. Now let us check AC belongs to or not. AC, that is 1 3 1 3. Yes, 1 3 is there. So this is R is transitive. R is transitive. If 1 comma 3 does not belong, or if 1 comma 3 is not present in this relation, it is not a transitive. First two belongs and we need to check the third. What is third? If AB belongs, BC belongs to R. We need to check whether A and C are also present in the relation or not. Here you can see AB, BC, and AC is also present. Then it is a transitive. If that was present, absent, that is missing, we say it is not a transitive. So this is very simple, my dear students. Is it okay now? Okay, have you understood this? This is the basic concepts, and very important are these last four definitions. Okay, and if a relation is all the three conditions satisfied, that is transitive, sorry, first one is reflexive, symmetric, and transitive. If all the three are satisfied, we call them as an equivalence relation. If anyone is not satisfied, or if it is a false from anyone among the three, it is not an equivalence relation. Okay. In the last one we have discussed here. Here you can see equivalence relation. If all the three are satisfied, then only it is a equivalence. If anyone is not true, if either it is not reflexive or not symmetric or not transitive, if anyone is false, then it is not an equivalence relation. Okay. So that's it, my dear student. This is the basics and the introduction class to the chapter number 1.